Hello everyone, welcome to your 9-4 lesson, the last lesson of topic 9 on hyperbolas. Our learning target for today, we will be able to understand the geometric properties of a hyperbola. We'll use the foci and distance formula to derive the equation of a hyperbola. We will write and graph the equation of a hyperbola and use it to model a real-world situation. All right, so what are these hyperbolas we speak of? A hyperbola is a set of points, P, such that the differences from any point P to two fixed points, or foci, is constant. So if we look at our little picture over here, we've got our hyperbolas. So this hyperbola is formed by a collection of all of these points. Any point on the hyperbola, if you take the distances from the hyperbola to each focus, those are the fixed points, our foci, and find the difference of those two distances, it will be the same number every single time. So I could find a point here, calculate the distance to F2, calculate the distance to F1, our two foci, subtract those, and I'll get the same difference every single time. All right, the foci of a parabola, that is going to be, at least in this picture, the F1 and the F2 points. Our C value, let's make a note. Our C is going to be equal to the distance from the focus to the center. So if we look at the picture from the focus to the center, that's what our C value is going to be in a hyperbola. And then the other focus is the same distance away from the center. We have vertices of a parabola. We can see in the picture there's a vertex here and a vertex here. Notice that the hyperbola has the focus on the inside of it, similar to our parabolas. The vertices will lie on the transverse axis, which we'll talk about next. But we can make a note that our A value is going to be equal to the distance from the vertices, or from a vertex. Maybe we should say a vertex, to the center. So looking at the picture, from a vertex to the center, there's your A value. Vertex to the center, there's the A value. So in this one, you can see that the C value, that distance, will be greater than the A value. All right, transverse axis. This is the axis that contains the foci and the vertices. So in this hyperbola, the transverse axis is horizontal. When you have a horizontal transverse axis, your hyperbolas will open right and open left, like that. And then we have our conjugate axis. This axis will be perpendicular to the transverse axis, and it will pass through the center of the parabola. So in our picture, we had a horizontal transverse axis, so the conjugate axis is perpendicular to it. The center of our hyperbola is going to be the intersection of the transverse and the conjugate axes. So if you look at our picture, here's the center. This is where the transverse and the conjugate axes will meet. I just noticed that I don't have asymptote on our list. We're going to put that in our next video, but just to show you a visual, you do have asymptotes in hyperbolas. They're going to be intersecting lines like this, and essentially it creates a guide for your hyperbola. Our hyperbola is going to head toward the axis, but never touch it, and then head toward the other axis and never touch it. And it just kind of guides how wide or how narrow that hyperbola curve will be. And we have specific equations for the asymptotes.